a very warm welcome from my side. I'm really pleased that you're attending today's session, Measure Accurately, Analyze Efficiently, and Manage Professionally Measurement Results. My name is Christoph Heller. I work at Vector Informatics in the area of analog measurement technology as a business development engineer. Today, I'd like to talk about the Vector CSM e-mobility measurement system. I know in previous CSM Xplained seminars, you already have been informed about this solution, its applications, its use cases. And so I'd like to focus today on a specific topic. But before doing this, I'd like to mention that this Vector CSM measurement system, with its capabilities, its features for fast, precise, high voltage safe, time synchronous measurement capabilities, it perfectly meets the requirements of e-mobility measurement applications. Today, I'd like to focus more on the analysis, on the evaluation of the signals, of the message data, to get the kind of information you are really interested in. And this even in large amount of files with many signals. And a specific focus will be today how to do this fully automatically, how to acquire the data automatically, how to visualize, analyze the data automatically, and finally, how to automatically create the reports and get the kind of information you're really looking for. So to get a hint how to optimize your system, how to change the setting with a goal to get the best results of your system. So in order to get started, please consider yourself in the role of a responsible system engineer for the high voltage electrical system. You are responsible for a brand compliant behavior of your vehicle. You are responsible for a dynamic driving behavior. You are responsible that all consumers in the network are powered with enough energy. You are responsible for reliability of the network. And finally, you are also responsible to achieve high driving ranges. Especially high driving ranges are very important to achieve good market acceptance and also to achieve good market competitiveness. In order to get the overview of the high voltage electrical network, you have to do a lot of testing. A lot of testing and measurements. For instance, you have to control the battery. You have to control the power flow. You have to do measurements in the inverter and so on. So a lot of measurements. And for this, you need a precise, fast, time synchronous and high voltage safe measurement technology. Specific focus we will have here on the powertrain area. The core powertrain with the battery, the inverters, and the e-engine, the electrical engines. So now let's have a look to the measurement setup because we want to do the data analysis later on with real measured data. So the measurement setup in the powertrain consisting of battery, inverter, and e-machine, e-motor, is done here by equipping high voltage breakout modules between the battery and the inverter and a BM3.3 between the inverter and the e-motor in order to get the information, the raw data of voltage and power. And the high voltage breakout modules perfectly meet these requirements by precise measurements, by measuring capabilities with up to, 2 megasamples per second data rate, also being able to measure quantities of current and voltage 1400 amps and 2000 volt peak. And due to the characteristics of the HVBM modules, they can be used in laboratories, at test benches, and also in mobile applications. Furthermore, we do the data acquisition with Canopy and vMeasure and with the integrated e-mobility analyzer. As we have to analyze the inverter and the e-motor, we use here two specific functions, the inverter efficiency function and the e-motor power analysis function. And for later analysis of the measured results, we use here the offline tool, the vSignalizer, for offline data visualization, analysis, and report generation. And as we have to work with a lot of files with huge data, and if we want to exchange and collaborate with different teams, we have the vMDM system for fully automated data handling here in place. We did the measurement in an aircraft. The aircraft is a sports aircraft, and the e-motor shows, I have to look up for the values, a nominal voltage value of 60 volt, current 300 amps, and a nominal power value of 16 kilowatt. All right, and now let's have on the next slide a look to the measured results. Those results are now visualized in vSignalizer. So we see here the raw data. In green color, we see here current, and in red color, we see the voltage being measured between the battery and the inverter. So again, measured with a data rate, measuring data rate of 1 megasample per second. Looking at those signal values, I think this looks pretty fine. The RPM values increased parallel with an increasing current. Due to the internal resistor, the voltage shows here a little drop. The next diagram shows here inverter efficiency, lambda, and also here the e-motor power analysis factor. And what we see here, there's a dramatic drop in inverter and power e-motor power factor. And those kinds of facts have a big impact on the overall behavior of your powertrain system. This has a big impact and has to be analyzed in more detail. So if you look inside the combination of inverter and e-motor, we look, for instance, here in one specific winding of the e-motor. In order to get here real values, we have to apply a triangle star conversion, and then we have here the apparent power. And what we recognize here is there are peaks, negative peaks, that have a big impact overall on the behavior of the motor and the inverter, because these negative values cannot consume, or the related power cannot be consumed by the motor. It will be reflected to the inverter and they are consumed as heat. So it's definitely losses. And this is something you as the systems engineer, you have to avoid, because you have to take care that in all situations, regardless in an aircraft or a car, you have an optimal behavior. So power losses, drops in efficiency cannot be managed. So you have to improve the situation by modifying the software version, by modifying the calibrations, by modifying the settings in the overall powertrain systems. And that means due to the different variations you have to apply, you will get a lot of testing. And for each test, you will get a test result, a measurement file. And just to give you some figures, Just if you calculate before and after the inverter, you have 8 signals. With a data rate of 1 megahertz, you will have a overall data rate of 22 megabyte per second. So that means you have very large amounts of data, big files. And what we have seen before, with one file, you can analyze this manually. But I would say if you have to analyze hundreds of files, you are not interested to do this manually anymore. So in order to manage those files, you must have an efficient and secure storage system. You must be able to identify the measurement files clearly concerning software level, concerning calibration levels, concerning objective of the tests, and so on. So that means you have to have kind of description capabilities. We call this meta information. And from the measurement files, you have to extract also the relevant KPIs. And what we have seen on the slide before showing the signal behavior, you need efficient methods. Definitely you need it in an automated way to look and to search for those effects. And then knowing the software version, knowing the calibration level, you know specifically which measurement setup you have to optimize. And again, in one file, in 2 files, you can do this manually. But I'm not interested to do this in 10 files, in 15 files, 20 files, or even hundreds of files. So you need an automated way to do this. And therefore, we'd like to introduce our vector measurement data management system. It's a proven system in place since many years, and it's our solution to efficiently manage large amount of data from development, test benches, and driver tests. And the key information is that management and analysis of the data is done in the cloud or alternatively in a backend system. Here you already see some reports typically generated by vMDM fully automatically. So characteristics are secured storage, protection of data against unauthorized access, support of worldwide distributed teams. And I think this is a key criteria. Extensive analysis routines run in the cloud. That means they don't have an impact on the performance of your local desktop. And again, such kind of reports, the index reports or the Castle PDF reports can be generated fully automatically. And that will allow you to get an overview of the overall system behavior. Now let's have a closer look to the vMDM system. So the goal of vMDM in this case here today is to provide fully automated data handling from the data source until we have the final reports on our computers. Measurement file could come from fleet loggers via Logger Cloud or from the test bench automatically uploaded with PowerShell scripts, or from the Windows Explorer, or at the end of a measurement in Canopy or vMeasure. These are some examples of sources of the data for vMDM. Important, and I think that is a major criteria, a major feature of vMDM is its powerful pre-processing engine. Here you derive all the information you are looking for. It could be, for instance, driving distance, average oil temperature, or even those small time slots when you recognize an efficiency drop, a drop in the power, a drop in efficiency. And this information is then efficiently stored in the metadata index and available for later analysis, post-processing, and reporting. Another key feature of the vMDM Professional is that you easily can configure the system with the front-end tools vSignalizer and Canopy. So if you are already familiar with those tools, it's just a mouse click away to configure the system in vMDM Professional. So it's not a long learning curve. It's not related that you have to attend a lot of trainings. You can just reuse the already available algorithms that have you been used in the local canopy or the local vSignalizer. And again, also according to defined cron jobs by vSignalizer or canopy, you could generate those reports in format display pages with the kind of information you're interested in and looking for. And a nice convenience feature is that you also can forward your reports by email notification. If you want to have a closer look inside the measurement file, then you have the Signalizer or the canopy as front-end tool. So those tools provide the main access point to the measurement data, regardless whether it's in the cloud or in a server backend. So here you see the Explorer with the measurement files and all those descriptive information that we call meta information. Here you see the characteristics of the engine, of the inverter, of the vehicle, of the powertrain system, and whatsoever. This is what we called the static meta information. And also, you have here the capabilities to highlight the information being derived during this pre-processing analysis step, like number of gear shifts, and also the number, how many times you detected this performance decrease, this efficiency loss, this efficiency drops in your measurement files. So furthermore, you can have here in various access points, access to various vMDM collections, storage areas defined according to your needs, your project environment, and so on. And again, it's a front-end tool to design pre-processing, post-processing, and reporting steps. You have here access to the results. And finally, you can conveniently search for the measurement information you're really interested in. And after a lot of this information, I'd like to show you this now in a real example. So for this, I'm going to share my screen. And here I have the canopy. So you see here already what we call the vMDM Explorer. You see here the different measurement files that have been measured in our sports aircraft. So it's real data, real files, nothing manipulated. It's the data being collected, being measured with canopy and the fast, precise, and high voltage safe measurement modules from CSM. Okay, at the moment we have 5 files in the cloud. Now I'm showing how easy it's to upload one additional measurement file here from the Windows File Explorer. Just here click on Files to be copied in to this collection. You can control it by looking at the notifications dialog. And then you see here, while the file is currently uploaded to the vMDM system. Now, I'd like to give you a hint. For these already uploaded measurement files, we have here the information, how many abnormalities, how many performance drops, how many efficiency drops have been recognized during the upload of the measurement files. And this is here number of hits. So anytime we detected a performance drop, we have here an entry. And now please consider not having only 5 files, but hundreds of files. And you say, okay, just in the case, if you recognize more than 5 hits, then the file is critical. So for this, I've created a filter. And now I activated the filter. And it shows me that there are 2 files showing a bigger number of abnormalities. And now you could have a quick look inside the files. And this is very simply done just by a double click on the measurement file. And then it shows here on the left-hand side in the Symbol Explorer. Here you find very easily the raw data, voltage and current. And also here we can load further information after the inverter, feeding in the voltage and current into the e-motor. So that means the files, even if they are somewhere around the globe being available in the cloud, you have access to the data within a minute. So that means you can access the data from all around the globe. Even your partners, maybe in America, in the Asian region, could have access to the data very quickly. Now I'm cleaning the filter. And now we have seen, while I've been loading this measurement file for visualization purposes, this measurement file has been uploaded also here to the cloud. So here also what you can do here, you can dive in and look for the details, looking for the correlation between the signals and get the kind of information you're looking for. Now I switch here to the result page. And here we see a result file, a report that has been defined in order for this seminar. We see here a nice front page, a display page, with maybe it could show your logo, your project information, very descriptive. And on the next page, we have a summary page where you say, okay, what's been the system under test, what's the project, and here also, what is the relevant software level, software version and calibration version. And here on the next pages, you find the signals. So here you see, again, this dramatic efficiency decrease. So a couple of times you find here this drop in efficiency. And this is shown here for every file. So that means as soon as the data is available in the vMDM system, it is analyzed in the pre-processing step and then available to create an overall report. But more important is, and that is something I'd like to, if I go back to the measurements again, and I run here again, here, this filter, that means you see here this measurement file. And this measurement file is based on a configuration of a battery with 45 kilowatt hours, and the inverter is based on software level and calibration. So that means you directly get the indication that based on this software level, you should do some modifications. So an automated way to detect the power loss, the efficiency drops, will provide a link to the relevant software, to the relevant parameters, to the relevant settings in the powertrain system that has to be optimized. So, and in our case, it's just 5 or 6 or 7 files. That's not a big deal. Please consider hundreds or thousands of measurement files you have been done maybe in a week or in a couple of weeks with different test vehicles in a vehicle fleet. This will help you to detect the software levels, the calibrations, not yet fully optimized, just with one mouse click, clicking here on this filter criteria. Now going back here to my PowerPoints. Okay. Again, I think this is a key feature of vMDM. You have seen this fully automated processing. You get the information, what you are looking for, without any manual impact, without time-consuming searching in hundreds of measurement files. It's just a mouse click away. And you already get a direct indication of the software levels, of the configuration, of the calibration parameter sets that do not show optimal system behavior. And if you then do a double click on the measurement file, you can start with an immediate detailed analysis in the vector vMDM front-end tools. So it's really a powerful mean supporting automated data handling, directly indicating the critical points and guiding you in the direct correction, in the best direction in order to solve the problem and to improve the system behavior. So only a few more hints. Pre-processing, this data analysis engine, analyzing every uploaded files. This is the area where your experts should provide the analysis routines, because this is the point in the overall data handling flow to get the really important information. Some customers use this in order to detect maximum of currents, of the voltages, or they count the gear shifts, or they calculate average oil temperature in intercity test drives, or they get a clear indication of the switching times. And also there they have the possibility to aggregate data from other systems, maybe diagnosis information, in order to have, together with the measurement system, the measurement file, the measurement configuration available. And this, I'd like to say, can really be done with the base mathematics, base Boolean, base statisticals, and also the base routines of the e-mobility analyzer function library that is available in Canopy or vSignalizer. So it's really intuitively to be used. Even if you say, okay, you have under a different file format, the raw data format, maybe from the loggers, can be converted to the standardized, powerful MF4 format. Again, pre-processing is done, and also post-processing and the reporting routines are done with the standard Canopy signalizer routines. So no specific trainings, no other tools are needed to define the analysis, the computation, the report generation in vMDM, in the cloud or in the server backend. So let me summarize. The overall goal of the Vector CSM e-mobility measurement system is to provide a complete tool chain from the measurement point, measurement tools, data acquisition tools, data analysis, and cloud-based data management from one supplier, and that is the partnership between Vector and CSM. And doing this, we provide a fast, precise, high voltage safe, flexible measurement solution. And due to the robust CSM measurement technology, all data is captured in a high, accurate way. And also due to the small dimensions, the CSM modules can be instrumented close to the measurement points. You have synchronous recording, you have time synchronous recording with quality levels less than 1 microsecond. And all kind of analysis computations can be done in the cloud and are only one mouse click away to get the results, to get the files for an intuitive, detailed analysis in the vMDM front-end tools. So I hope you could get in this seminar a first good overview of the Vector CSM e-mobility measurement system with a specific focus on automated data handling, on analysis, and also on modern cloud-based tool environments. In case of any questions, please feel free to contact us or visit our homepages at www.vector.com or at csm.de. Thank you very much for your time and your interest.